Hello, Hornets. In this video, we're going to be taking a look at how we use our calculators to find the intersections between two velocities. So the question is asking us to take the two position functions and determine how many times their velocities will be equal from 0 to 1.5 seconds. Now we could take the harder route and we could find those derivatives by hand using our chain rule with explicit differentiation. Or we could put everything into our calculators and let the calculators do it for us. That's supposed to be a T there, by the way. So let's go ahead and do that. We're going to put our information in the calculator. We're going to have it do everything for us so that we don't have to bother taking our derivative. It should go a lot faster, and we should get it right without much difficulty. So we're going to start by putting into our calculator under S1 and S2 the two equations. Now you'll notice there's a sign squared here. So we're going to have to use parentheses around the sign of 3t squared plus 2 and then put our quantity squared. So we can't write it the same way, and we have to be careful with that. So let's go ahead and zoom in on our graphing calculator. We're going to put both equations in as best we can. So we're going to use parentheses, sine of 3, and we use x squared instead of t, and we have plus 2, close parentheses squared, minus 1. Now that's the first thing you've got to remember, is when you see the power in a sine, a cosine, a secant, whatever it is, make sure you use parentheses around the entire thing. The second equation we had was 1/4 e to the negative 3x. So I'm just going to do it real quickly. 1 divided by 4 e to the power of negative 3x. Now, these are our position functions. These are not going to do it for us. In fact, as we were talking about, we really need to find the velocities. So I'm going to turn both of these off so that when I graph, they don't show. The more graphs we have, the more complex it looks. So we don't want that. Now, we've already talked about how do we find a derivative. Finding the derivative is under Math 8. So you are expected to hit Math followed by 8. And you're going to put an X. Now, for those of you with the old calculator, that's that n derive. Remember, y1x, and we're going to put at x. So I'm going to put my y1 in, and I'm going over all x values. Now, putting an x back there after the equal sign, what that does is it means I'm going to get a graph, all right? I'm going to graph that's going to show me all of the velocities at any time t. We're going to now repeat the same process, but we're working with number 2 equation. So Math 8, we have x as our variable. We're working with y2, and we want over all x. Now, once we've got this far, they gave us an interval from 0 to 1.5 seconds. That is important to us. We have to go to our windows, and we have to put 0 to 1.5. I would then follow with a zoom fit and see what happens. If the graph is too large, we'll crop our values in our windows again, and we'll try to get the best fitting line. Now be aware, by doing the derivative of a position function, it does take a little bit longer, but it's still graphing a lot faster than if we had to take our derivative and not know whether we did our derivative correctly. So this takes away some of that angst, that anxiety that I might get my derivative incorrect, something I wouldn't want. So our goal is to find out how many times the velocities are equal. When they intersect, that's an equivalence. We're looking at 1, 2, 3, 4, 5 times. 5 times to find the intersection. Okay, now we could then find what those values are. That would be the second trace feature, followed by finding the intersection 5. And we would move to the closest intersection we want, followed by enter, enter, enter. And we could find each x value where this intersection occurs. The first one is at point 111. So they could ask, find the first time these two velocities intersect. That's a possibility. Okay. They could ask us in the find the second time or the third time or the fourth. List them all. All right. So let's just repeat that again. We go to y equals. You put in your two equations. I'm going to delete them so that we can do it over again. Hit math 8 x, for those of you with the n derive, y1 comma x comma x. Oops. There's our first. We go to the next one. Math 8, x is the variable. We want y2. As it all goes along, we've done this before. It shouldn't be too difficult. Hit the x. The x allows us to graph it now. So we're going to find a dynamic graph. Our windows were 0 to 1.5. We hit zoom fit and we let it graph. What we're looking for is where these two velocities intersect, or how many times they intersect based upon the question. In this case, we saw that there were 5 intersections. As this black line finishes, we clearly see it from this purple line coming across, or violet. We have 1, 2, and we can predict 3, 4, and 5. This is what we're trying to do. I hope this made sense, and please practice it with the practice that I provided for the preparation for Quizzle number 4. Thank you very much, Hornets. I hope this was positive and was helpful. Thank you very much. Be well, be safe.